Saxon Advanced Math, lesson 64C. This is sums and products of complex numbers. Now, first thing that I'm going to show you is just how to add a complex number together. We already know when we're doing this, we wouldn't really even need the parentheses, right? We could drop the parentheses and just say 3 and 2 is 5, and 2i and 3i is 5i, and we know how to do that. And the book example is a little more in depth because they had 2 root 3 and they're going to add it to 2 and you really can't do anything. And 2i and 2i, and that's going to add to 4i, and then they put the parentheses on here to make it in the correct format, which is real plus imaginary, right? And I've even seen some people, they would factor this 2 out to the front, making it 2 root 3 plus 1 plus 4i, and that's still real plus imaginary, so that's fine. Now, unfortunately, in complex numbers, just like in rectangular numbers, I cannot add polar forms that do not have either the same angle or an angle 180 degrees removed from the original. Now that sounds confusing, but let's look at this. If I said add 4 CIS plus 2 root CIS 45, I can't add these because I'm adding. What do? It's not 40 and 35. I'm not adding. I'm not getting 75 degrees. That's weird. So I can't just add those. But if I'm multiplying, that's another story. Let's move down to that here. We're going to look here at 2 root 3 plus 2i and 2 plus 2i, and I'm going to multiply these. Now, if I'm going to multiply these, and if you're looking at the book example, they used vertical multiplication. You can do so, and that works just fine. However, I prefer to go ahead and just use FOIL. It works just as well. 2 root 3 times 2 is 4 root 3. 2 root 3 times 2i is 4 root 3i. And then I move to the next term. 2i times 2 is 4i. And then 2i times 2i is 4i squared. So when I look at this, I'm going to immediately be able to simplify 2i squared, right, into a negative 4i. And when I convert and combine my like terms, I'm going to end up with 4 root 3 minus 4 and 4 root 3i plus 4i. Now, because I have to be in the correct format, which is real plus imaginary, I go ahead and put parentheses on the real portion. That's my real part of the number, plus the imaginary, but I need to go ahead and factor out the I, so I only have one I in the answer. There's 2 reasons for doing that. The first is it puts me in the correct format, because there's always one I. The second is it makes it so if I did have more than one I, or I squared, or I cubed, I would simplify that down only to one I by taking out the squares. Now, what they're looking for us to see at this point is if I used a calculator and said 4 root 3 minus 4, that would be 2.93 if I just stuck that in the calculator. If I said 4 root 3 plus 4, that would be 10.93. If I took this number and converted it, like we did in the first section, into the complex number set of polar form, we would take this and say 2.93 and 10.94. Remember, real and imaginary, okay? This R is capital. I put it as a capital so you can see it has to do with the hypotenuse there, not with the axis point. At this point, I'm going to look at it and say, well, if I want that theta, I'm going to use the tangent. And tangent is opposite over adjacent. That gives me 74.993, or about 75, as my angle. Then I go ahead and use Pythagorean theorem, right, to find out the radius. I'll get 11.31. This format, therefore, would be a 11.31 CIS 75, right? Cosine I sine. Then when I convert it into that. Now, let's go ahead and talk about if I were just to take these two. These are the same idea. These are the same numbers, but they're already in CIS format. 4 CIS 30 and 2 root 2 CIS 45. What I'm going to do is I'm going to take the radiuses and multiply them. 4 times 2 is 8 root 2. And then I'm going to take this CIS, bring it down, 30 and 45. This is where it's different. I simply add the angles. That gives me 75. If I did that, 8 root 2, and did it on the calculator, I get 11.31 CIS 75. Look at that. It works out really well, and I can do so. So when I'm multiplying out polar format of complex numbers, I'm simply multiplying the coefficients and adding the angles. 64.1 is very similar to this, and we'll look at that really quickly here. They said multiply these two, and notice that this is cosine I sine in here, but we're going to go ahead and just rewrite it as 5 CIS 20, right? 5 CIS 20 degrees, and 6 CIS 42. When I multiply this, 5 times 6, I get my 30. My 20 and my 42 is 62. Now, there's another special case that 64.2 covers, and it's very quick and very easy. They only asked us to multiply these two, and you'll see how this works. 5 times 7 is 35, very easy. 280 and 300 is 580. Now, this is where what's new and they're asking you to notice, and that is 580 is greater than 360 degrees, and I can't really tell a difference every time I go around 360, right? It ends up the same thing again. So if I subtract the 360 that I have out of there that's unnecessary, I get 220. That gives me 35 CIS 220, and that is the multiplication of the two complex numbers in polar format.